This is 5.5, number 11, and we are going to use symmetry to make our life mucho better. Even though you don't see it, this has an x to the 0 power, which makes it an even term. So these are odd, and these are even functions. So we're going to split it up into two separate functions, because we are allowed to do that according to the rules of integrals, or the properties. And then we're going to start using some shortcuts. The first shortcut, if you have an odd function from a negative to positive value, that's going to be 0. So that, we're done. That's 0. Then the right side, we have the property. I can just do, if I want to, I can just double and only go halfway. And I'll explain all this in a second here. And now I just continue the process of the fundamental theorem. So the antiderivative, add 1 to that and divide by that. So it's 2x cubed over 3 minus 10x from 0 to 2. I plug in z2. So it's 2 times 2 cubed over 3 minus 10 times 2. And then I plug in the 0, but I think you can see when I plug in 0, these will both be 0, so it's just 0. And now that's going to be 16 thirds minus 20. Should I distribute the 2? I don't know what I'm going to do. I'm going to get a common denominator of 3. So we have 16 thirds, and it's going to be 60 thirds, which will be negative 48 thirds. Is that right? 60, 40, 56. No, 44. 44. I think it's 44. 40, 50, 60. Yeah. And then times by 2, I get negative 88 thirds. Does that make sense? What number was that? Number 11? Bam! That number looks so weird. I thought I was wrong, but it is right. So what just happened? This is odd, and an odd function is symmetric about the origin. Now, this is not what this one looks like. I don't know what this one looks like, but I'll give you an example of odd function. There, where this side kind of matches that side. But when you integrate from minus a to a, it should be apparent that that area there and that area there are going to be the same, but one's above and one's below. So when you get the net area, it's going to be 0. That's why that was 0. And then let me show you kind of the other side, what's happening. An even function is going to look the same on both sides, like a mirror reflection. Well, that's supposed to look the same. And if you integrate from minus a to a, now it should be obvious that this area and that area is the same. So instead of integrating across the whole distance, we just go half of it, 0 to a, and double it. That's why I doubled and went from 0 to 2 instead of negative 2 to 2. So that's what happened. And that's number 11.